Hello. Welcome to O Levels Chemistry, and this topic is covalent bonding. We're going to start with bonding, and this is your instructor Rani Saida. Now let's define what is actually covalent bond. Covalent bond is actually formed between two atoms by sharing electron. It is the bond which is formed by sharing of electrons between atoms. The electrons are mutually shared or held between two or more than two atoms. This is called as covalent bonding. And the purpose or the objective behind this is again to attain stability. After sharing of these electrons, the atoms, they try to become stable just like noble gases. Means they are struggling to complete their duplet or octet by sharing of electrons. Now, as a result of this, the compounds which are formed, they are called as covalent compounds, and the molecules are formed as a result of it. The smallest units. A molecule is actually a group of two or more atoms held together by covalent bond. Group of atom held together by covalent bond. Now, it is the specific ability of actually non-metals. They are involved in sharing of electrons, and they tend to attain the electronic configuration of noble gases by this strategy. There are three different types of covalent bonds. Single covalent bonds, when a single pair of electron is shared between two atoms. When a single pair of electron is shared between two atoms, this is called as single covalent bond. For example, hydrogen molecule, for example, chlorine molecule, for example, HCl. These are some common examples. Let me show you one or two. And we just draw the last shell to indicate the sharing of the electrons. Let's see what is actually. This is hydrogen, and we have one electron. It has one, and another hydrogen we draw. It also has one electron. So both of them, they share their electrons and they form H2. Similarly, if we draw chlorine, hydrogen chloride, this is chlorine last shell. I'm going to just draw the last shell, and in last shell it has 1 2 3 4 5 6 7, and as a result of sharing, what happens? This is hydrogen and this is chlorine, and the electrons, the shared electrons, are held over here. Shared electrons are held over here. This is mutual sharing of electrons. Let's talk about double covalent bond. When two pairs of electrons shared between two atoms. Two atoms are there and two pairs are shared between those two atoms. For example, O2, oxygen. As we know that oxygen belongs to group 6. Once again, the same strategy. It has 6 electrons in outermost shell. So needs 2 more to complete octet, and that can be done by mutual sharing of these two electrons. Let me draw it for you. This is oxygen nucleus, last shell, having how many electrons? 6. 1, 2, 3, 4, 5, 6. These two will be shared with other 1, 2, 3, 4, 5, 6. And finally we come up with an oxygen molecule in which there is 2 pairs are shared and rest are there. One thing you need to do is please recount it after sharing, that whether your objective of getting octet is completed or not. 1, 2, 3, 4, 5, 6, 7, 8, and this is how you're done with it. Let's talk about triple covalent bond. Triple covalent bond is the bond in which 3 pairs of electrons are shared between 2 atoms. For example, one of the great example is nitrogen. Nitrogen belongs to group 5 and it has 5 electrons of its own plus 3, so it means 3 electrons are needed which they can share by themselves. This is nucleus, and how many electrons it has in outermost shell? 1, 2, 3, 4, 5. The ones which are going to be shared, I have drawn them on one side to make you a clear understanding of it. 1, 2, 3, and these are the 2. What will be the sharing result is there, and the one which are shared, 3 pairs, 1, 2, 3, 4, 5, 6, these are shared, and rest of the 2 are, let me draw it a little clear. This is, yes, like this. And now 6 electrons or 3 pairs, 1, 2, 3, 4, 5, 6, and these are the unshared pairs. We call the shared pairs as bond pairs, one thing important, and the ones which are not shared, they are called lone pair of electrons. They are called a lone pair of electrons. Okay, let's talk about the examples of some of the important covalent molecules. Methane, if you have to draw the structure of methane, it is CH4, one carbon is there. First of all, once again you have to work on each atom forming that compound. Carbon belongs to group 4. It means it has how many electrons of its own? 4 electrons. And how many it is going to share? It needs 4 more to complete octet, and hydrogen belongs to group 1. It needs 1 more. So the atom which is going to share the more electrons will be drawn in the center while drawing the structure. It is carbon because it is going to share 4 electrons, so it will be coming in center with its 4 electrons. 4 hydrogens, each completing their duplet with the help of its duplet with the help of carbon. This is structure of methane. We also draw it like this. Let's come to ammonia. Ammonia is NH3. Nitrogen belongs to group 5. It has 5 electrons in outermost shell. It needs 3 more to make up 8. Whereas hydrogen, 1 needs. So nitrogen needs more electrons. Nitrogen will be in the center with 5 electrons in outermost shell, out of which 3 are shared. So 3 will be drawn like this for sharing purpose, separate, and 2 which are not shared. And each of them is shared with hydrogen. This is how ammonia is there. Let's come to water. For water, we have once again the formula as water. Hydrogen belongs to group 1 electron, so it is forming -1. It is forming it needs 1 electron to be shared, and oxygen belongs to group 6, needs 2 electrons. So oxygen is sharing more, so oxygen will come in center with its 6 electrons, out of which 2 are shared with hydrogen. This is oxygen having 6 electrons, 1 2 3 4 and 5 6. These 5 and 6th one is going to be shared with hydrogen, and after sharing you can count octet is complete and duplet for hydrogen is complete. Let's talk about carbon dioxide. This is CO2. C belongs to group 4 and it needs 4 electrons. Oxygen belongs to group 6 and it needs 2 more electrons to complete. So more electrons for carbon are needed, so carbon will come in center, and it is going to share its 2 electrons on one side with oxygen and 2 on other side with oxygen. So this is oxygen 1 2 3 4 5 6, oxygen 1 2 3 4 5th and 6th, and it is an example of double covalent bond. All right, represented as 2 lines on both sides, CO2. Covalent substances can have both simple type of structure as well as some of the covalent substances have joint molecular structure as well. For simple molecules, they have low melting and boiling points. They are volatile and soluble in organic solvents, and usually they are poor conductors because they don't have ions and they cannot conduct electricity and heat. Whereas if we talk about joint molecular structure, we have covalently bonded atoms, multiple numerous covalently bonded atoms, and joint network is there with high melting points. The examples being diamond structure of diamond, graphite, the sliding structure of graphite. Then we have silicon oxide. If we look at the properties of these diamond and graphite, we can see that diamond is hard, the hardest known substance we have, and it has the it is one of the allotropes of carbon, and each carbon atom is located joined to 4 other carbon atoms, and one of the hardest known substance and with highest melting and boiling points. Similarly, if we have a look on the diamond is poor conductor actually of heat and electricity. If we look at the properties of graphite as compared to diamond, it is slippery. It is having a slippery touch. Then it is good conductor, heat and electricity, and relatively low melting point and boiling points as compared to, and it is softer form. It is also allotrope of carbon, but it is softer, and it is used in as brushes for electric motors, and it is also used as dry lubricant. Silicon oxide, it is also forming silica, which is commonly known as silica, and it is also a tetrahedral structure in which each silicon is in which four silicons are bonded to one oxygen. You can see these are silicons, small dots, and this bigger one is oxygen, and this is also having high melting points. High melting points are there because they are held together by silicon and oxygen. They are held together by a network of covalent bonds that makes it more strong and relatively difficult to melt. So you can see that how joint structures in covalent they affect the properties of the substances as well, compounds as well. There is a practice question now. You can, as your assignment, please practice it, solve it, and then state your answers in feedback or comments box. With this, thank you very much.